There she is on certain Crown Vics of certain years. I believe at least 2003 up till in 2004 for sure. Have a solenoid that controls the power steering pressure, which changes your assist depending on road speed in the Crown Victoria and other Ford cars. But anyway, this has a control module that's installed inside the car. When you do a Crown Vic swap and steal the whole front suspension off, what do you use to control that solenoid to give yourself power steering? When you just unclip that thing or don't have it connected to a VAPS module, you basically have very little, if no, power steering. So drives fine when you start moving, but parking lots are terrible. Basically, it feels like you're driving a manual steering car. So there's three options. Yank this entire rack out and put in the later model, kind of more of a fixed booth that does not have this module, which is obviously expensive. It also needs to be paired with a different power steering pump because there are two different part numbers. There's a part number for a steering pump with the VAPS, and there's a part number for a steering pump without the VAPS. So it probably has different pressure ratings. So that's one option. Change power steering pump, change it to a newer rack that doesn't have this VAPS module or VAPS solenoid. Option two, really expensive probably, is yank it out, put an electric steering in from, let's say, a Mustang. That seems to be a common swap. Also, again, also expensive and complicated. Or third option, install a pulse width module controller to control the VAPS solenoid and get yourself some power steering back. Now, this option does not give you variable power steering. You basically buy a pulse width module, PWM module, that can handle the current, and you set it to a fixed position to whatever boost you kind of like when you're going slow. And granted, it tends to feel slightly over boosted at speed depending on what you set it at, but it's variable, so you can kind of adjust to what you want, to your own personal taste, and then that's it. You just basically connect that solenoid to the PWM module and give it power to run when it's hot. I'm going to give more details here in the rest of the video, but for the nutshell, simple Amazon $7 to $30 PWM module connected to hot and run power, and the other pair on the output of this thing basically controls that little solenoid, and then you have usually a little potentiometer or a little what looks like a volume control to adjust how much pulse width it gives it to give you how much power steering you want. So that in a nutshell, and I'm going to cover a little more detail here next. So what do we have here? We have all the junk you need to make your PWM controlled solenoid work on your Crown Vic rack and pinion setup. So anyway, you've got it all done, yanked it all out, installed it, and found out you have no power steering. And here's the culprit. It is the PWM controlled solenoid that's mounted on the rack right around the steering gear there. And what that does is it basically controls the amount of pressure that goes to the rack, which gives you the boost, gives you the nice power steering. It is variable, so basically the engine computer and the VAPS module, is controlled by the computer, and it knows how fast the vehicle is going. And depending on the speed of the vehicle, it increases or decreases the opening in this valve, in this solenoid, to give you more or less power steering. So at speed, it has almost no power steering. When you're in a parking lot going incredibly slow, it gives you almost full boost, and everything's wonderful. Well, until you don't have a VAPS module. So how do you make this module work if you have no VAPS module? Well, the kind of go around or patch that you can do is you will no longer have variable assist. You will have a fixed assist, and you use a aftermarket separate pulse width module, PWM module for basically controlling the boost or operating that solenoid. So what happens is you use the PWM module. It takes a constant voltage in, converts it to pulse, and sends it out to the solenoid. So then the solenoid gets its pulse, and depending on the basically how fast or how the pulse is, you can increase or decrease the percentage of pulse. And then once you set it to where you got the correct or whatever you feel is the right boost, you basically can just lock this away and you're done. You just leave this. This is just a part that's sitting inside, your engine compartment, underneath your dash, depending on where you decide to put it. But this little module now allows, when the engine's running, to operate this valve, and it will basically take it to a certain point. So if you crank this to 100%, then it will basically probably open this valve 100% and give you full boost. And if you don't want as much boost, then you can crank it backwards and end up just having partial boost. That's about it. That's in a nutshell how it works. Now, PWM controllers and pulse width in itself is some form of, not really a mystery, but what it does is it takes a DC constant input and it basically flashes the output at a certain frequency and basically turns it on, turns it off, turns it on, turns it off at a certain frequency, 30 hertz, 60 hertz, whatever, depending on which PWM module you get. That in itself doesn't matter as much in this case, but what happens is it basically is just turning on the 12 volts for an incredibly short period of time and turns it right back off. Turns it on, turns it off, turns it on, turns it off. And that basically allows it to, in theory, limit the amount of current that is getting to this device. If you took this device and connected it straight to 12 volts, it will probably actually operate and give you full power steering right up until it melts. Because this is not designed for continuous, constant, direct current. It will operate and probably melt. So in this particular case, you have to use a PWM controller, to get the variability, because you may not want full boost, and also to keep this from melting. So what happens is when this thing's turning on and off to 12 volts at an incredibly fast rate, it's limiting the amount of current that is going to this. And that pretty much is what operates this thing. I'm not going to get into detail. If you want to look up PWM, go for it. But in this case, this is your basically magic module that lets you control this. And it's incredibly simple to install. I mean, I'm going to attach a wiring diagram so you can see exactly how it wires in. But in this case, here's the factory wiring diagram that shows you basically this is the solenoid that's mounted in the steering box, and you'll have a light blue yellow coming in, and generally that is the positive side. A light green black also coming in, and that is in your wiring harness. This module itself is usually located inside the car and is probably long gone. So, but in the wiring harness for the engine, you probably still have, if you use the factory wiring harness, these wires. You should be able to identify them. You'll have two ends. Those two ends basically go into where I've got these meter leads. And that is your output that sends a pulsed 12 volts to that solenoid. So then your input side, your power, would be basically your common, your negative, would go straight to your body ground. The one next to it is your positive, which would go to your switched on run, so it's only hot and run 12 volts, fused 12 volts. And then this would be your positive and negative output to that solenoid connected to the factory wiring. You can extend that factory wiring, or if you find it in a convenient spot, you can connect right to it. This obviously by itself, since it's an open circuit board, could not be just left laying around inside the engine compartment or even inside the cab. So a nice little hobby box, something like this, works really nice because it'll fit inside. Or in my case, what I did is I drilled the hole so that the little adjusting knob is outside the box, and that way when it's in the engine compartment or underneath the dash, whatever, I can always get to that knob. And if I want more power steering, I can turn it up. If I want a little less, I can turn it down. But for the most part, you're going to just adjust that to what's good and comfortable for driving through parking lots. And then, it'll be just like your normal car with regular power steering. So this is one version of a PWM. This is another version that actually has a display on it, but it basically operates the same way. It'll have 12 volt input, and then it gives you the pulse width output. And in my case, I'm just going to do this one because I can lock it inside the box. But when you're on Amazon or wherever buying these parts, I'm going to list what I bought and what I'm using. But almost all of them will work, but you really just need to make sure it's going to operate at 12 volts and be able to handle enough amperage. Since I don't know, there's no specs on how much current this thing needs, what I did is I figured worst case it can't draw more than 10 amps. So I got a unit that is basically rated up to 10 amps so that I could make sure that I don't melt this and it is able to provide enough current to have this operate and, you know, for longevity. But otherwise, it's really not that difficult. If you can just find these wires, get a module, get a hot on run, chassis ground, connect those wires to this, and your power steering is back up and running. So in this case, I've just got it set. I've got a little 12 volt power supply that I use just to test it before I even tried. And then this is a whole nother separate subject, but you cannot meter. If you tried to meter what voltage this thing should get, if you meter this positive and negative coming out going to a pulse width output, you will not get 12 volts. You're going to get some funny reading if your meter even reads it. So that's what a lot of people get confused on. It is still a 12 volt output, but it's turning on and off so fast, most multimeters can't read it. So that's why it's a mystery to most people. You have a direct current, 12 volts going in, and then you have to get a meter that actually has a frequency. I don't know if you can see that. Right there, this has a hertz. Pulse width is basically a frequency, and how fast it's turning on and off is the frequency, and then it'll also tell you what percentage that it's being turned on. And I'll show you that real quick here. So right now we're on. I've got my power supply on. I've got my LEDs on, and I'm going to show you the meter. I turn it to hertz, and it's going to show me basically what I have right now. I have 25.8. There we go, that's the frequency. Let me change the mode. There we go. And this is the percentage. So what does percentage mean? As I'm turning this thing back, I'm basically rolling it back to where it's putting out less and less. The percentage is how long it's on in each cycle. So when it fires on, it's on for 15 seconds and off for 85. And it's doing this incredibly rapidly fast. So basically what will happen is it's sending out 12 volts, but for a very short period of time. And as I increase this, and now it gets up to 25 and 30 and 40, and let's say 50% of the time. So at 50, it's sending out 12 volts on, and the off time is exactly the same as the on time. As I continue this up, it'll go all the way up to almost 100%, where now it's basically staying on longer and pulsing off for a shorter period of time. This is why you can't meter it with a meter. Meters kind of want direct power. They don't want something that's turning on and off like you're flipping a light switch incredibly fast. So you need to get a meter that has a hertz frequency on it so you can actually measure your actual outputs. And, you know, in this case, this particular meter is a Harbor Freight product. It's a DM500, and it has all the features. You can also use it as a regular meter, metering regular voltage. But in this case, it lets me meter my hertz so that I can actually go and measure, you know, actually I can test this. Now, I can use this not only for this, but most fans now are also PWM controlled. Variable rate fans for cooling on your radiator. So this is a good tool to get, whether you're going to be doing this kind of switch or test or not. You'll definitely want to have a meter like this if you're going to be working with any PWM style devices or controllers. It helps you kind of troubleshoot. In fact, if I turn this to voltage and I try to set this to where I'm going to get a voltage, notice this meter can read the voltage. A lot of meters, it won't even give you a voltage, or it'll bounce all over the place. This particular meter, because it's set up for frequency, will at least get me an average voltage. But you notice when I turn this thing down, it's giving me less voltage, but technically it's still putting out 12 volts. It's just putting it out at an incredibly fast rate. That's why you really can't trust this or put a regular, just try to feed this thing with 6 volts. If you do, you're basically going to melt your module. It's going to burn this thing up. You really have to have this thing be on a pulse width, turning it on, turning it off. Otherwise, you will smoke anything that's designed for a PWM input. So hopefully this makes sense. Either way, I will show a picture of the wiring diagram. And this is installed, test, and proven. And you do not have to use this particular one, but you do want to get one that has an input rating that will handle your 12 volts and a current rating of, I would recommend no less than 10 amps, because I really don't know how much current this thing actually uses. It's not a very large solenoid, so I would guess it's using less. In fact, I've got mine hooked up with a 10 amp fuse, and it's not blowing the fuse. Everything's working great. So I think I bet you it's probably only drawing 1 or 2 amps.